Good morning, everybody. So we are going to study the last chapter in chemistry. That is what is carbon and its compounds. Keep in mind, this is the basic chapter for your 11th class chemistry. If you are good in this, definitely class 11th chemistry, you will find many new things like organic chemistry. There is a separate branch of chemistry in 11th class, and there is a separate volume is also in chemistry book. So this is the main fundamental one. So which will make you very comfortable in class 11th chemistry. 100% I will give even that assurance if you learn this very perfectly. So let us, before going to start this one, carbons, compounds, what you learn in the last chapter is very, very important. Like last chapter we studied formation of compounds. You might be remember that formation of NaCl, formation of magnesium chloride, MgCl2, formation of HCl, many things we have studied. Do you remember everybody? All of you? Please respond. So formation of positive ions. I want that. What do you mean by positive ions? Everybody? Cations. Am I right? Please respond. So cations, we used to call it as a positive ions. So they will lose the electrons or they will gain the electrons. Everybody? Please respond. So cations will form by lost the electrons. Am I right, all of you? So next, same way, anions will form. Formation of anions we studied. So anions means what ions they are actually? Please respond. Anions means what is that? Negative. So they will form by lost the electrons or by accepting the electron, receiving the electrons. Everybody? By accept the electrons or by receiving the electrons, the atom will turn up into ions. So first remember, by loss or gain, atom will turn up into ion only by either loss or gain of electrons. So gain of electrons. If it loss, it will turn up into cation. If it will gain, it will turn up into anion. So that we will study that, and after that the formation of compounds we studied. That is what, how that electron dot representing formation. Many things I have taught you. You can check it. Formation of sodium chloride, formation of magnesium chloride. Most important one, even in our mid exam it has been asked there. And formation of magnesium oxide. Many, I think 5 compounds I have taught you, and along with that we studied 2 types of bonds there. Okay. Yeah, yes, Harish. SFS is there. You just avoid it. So 2 types of bonds also we have. What is the bonds we studied? Anybody tell me?
Ionic bonds, covalent.
Ionic bonds. And another one is what bonds? Everybody? Covalent bond. Okay. So ionic bonds basically will formed by metal will react with what, everybody? Non-metals. And covalent bond will formed by what, everybody? Covalent bond. It is only by sharing of electrons. Understanding? So sharing of electrons means non-metal and non-metal will react. So keep it in mind, this is the most important for this chapter. Ionic bond will basically formed by loss and gain of electrons. Understanding? Means one will lose the electron and another one will gain the electron. That is what we used to call it as a ionic bond. Am I right, everybody? Please respond. So they are formed by transfer of electrons from one atom to another. That is the meaning of ionic bond. If you take ionic bond, means transfer of electrons from one atom to another. So that is the bond we used to call it as a ionic bond. Now, as our chapter is carbon and its compound. So carbon. So what is the symbol of carbon atom? Everybody, carbon element? C. And its atomic number. Z is the symbol for atomic number. Class 9th. Do you remember, everybody? Yes, please. So atomic number if you have taken. So what is the atomic number, everybody? 6. So Carbon, if you have taken, atomic number is 6. And what is the mass number? Everybody. Mass
12.
12. Of course, this is the most standard form. It is having isotopes also. Do you remember isotopes, everybody? Same atomic number, different mass number. Maybe carbon existed C6-13 also. Carbon is existed C6-14 also. So these are the 3 isotopes of carbon. What is the meaning of isotopes? Anybody? Isotopes means same atomic number and different what? Everybody? Different mass number. Atomic number is same, but mass number is different. Different mass number. What is the symbol for mass number? Anybody? Teriyada? Yeah. Please learn. So if you forget it again, you learn. So element is represented with the 2 things. One is atomic number and another one is mass number. Are you clear now? At least do you try to remember, everybody? Yes, please. So that is what. So what is atomic number of carbon? Everyone? Atomic number of carbon 6.
6.
Now last chapter we have written electronic configuration, EC. So what is the electronic configuration of carbon? Make it quick, everybody.
2, 4.
Atomic number is 6. Atomic number is 6. So electronic configuration, please. Everybody. Electronic configuration is 2, 6. 2, 6. Now if you notice it,
2, 4,
2, 4, sorry. Yeah, 2, 4. So now if you notice it, what is the valence cell? What is the valence cell? L cell. So L cell, if you see, what is the number of electrons, everybody? Number of electrons? 4 electrons. So go back to the last chapter, metals and non-metals again. So we all notice it. What is the valences of metals? And we studied that. Metals and non-metals, whatever it is, first valence electrons. So metals and as well as non-metals and metalloids, whatever. So first valence electrons. What is the maximum valence electrons for every atom, for every elements, everybody? Either 1, 2, 3, 4, 5, 6, 7, 8. Valence electrons is 1, 2, 3, 4, 5, 6, 7, 8. Valency. Valency is how much, guys? If 1 is there, valency is also what? 1. If 2 electrons is there, valency is 2. If 3 electrons is there, valency is 3. So this is what we used to call it as. What we used to say, basically? We used to call it as a metals. Understand it? If 4 is there, valency is also what? 4. If 5 is there, 5 is there means what is the valency? 8 minus 5, which is equals to 3. 6 is there, 8 minus 6, which is 4. 7 is there, 8 minus 7, which is what? Everybody. Sorry, 8 minus 6, 2. And 8 minus 7, it is what, guys? 1. And last 8 is there, 8 minus 8, 0. So if 0, 8 electrons are there in the valence cell, we used to call something. Everybody? What is that gases we used to say? Noble gases or inert gases, or we can say stable gases or unreactive gases. And this 5, 6, 7, we used to call it as a, what we used to call, everybody? They are called it as a non-metals. Okay. But of course, middle, if you notice it, of course, the non-metals also having a valency of 4. But you remember, this 1, 2, 3, they will lose the electron. 5, 6, 7, they will accept or receive the electrons. But the 4, what is exactly present, they will neither receive or nor donate the electron. What they will do, guys? They will, yes, please. They will share the electrons. That is why the compounds formed by sharing of electrons, we used to call it as a what bond? Anybody?
Covalent.
Covalent bond. And that compounds, what is the compounds? We used to call it as, everybody? Covalent compounds. So the chapter, what is our chapter? Carbon and its compounds. The compounds formed by carbon. Every compound is a what compound? All of you. It is the covalent compounds. So complete compounds which is formed by the carbon is the covalent compounds. And you remember, basically, covalent compounds are strong or weak bond. Anybody? Which bonds are very stronger? We studied the properties of covalent bonds and ionic bond. Which is the stronger bond and which is the weaker bond? Anybody?
Ionic bonds are stronger.
Ionic bonds are stronger compared to the covalent bond. But keep it in mind, the bonds formed by the carbon, even though they are covalent, they are very strong and they are very stable in nature. The compounds are very, very stable in nature. Understand, everybody? And one more thing, ionic bond, ionic compounds are also called it as another name of ionic compounds. Anyone?
Electrical compounds.
Yes. So ionic compounds also we can call it as a, what is to call, everybody? Electrovalent compounds. Understanding? Electrovalent compounds. And covalent bonds also we can say. Anybody? Yes, please. Covalent bonds, another one. Another name of the covalent bond. Anything I have told you? Hurry. Yes. Ionic compounds, we can say electrovalent compounds. Covalent compounds, any name I have told you, Ma? Yes, please. No. Okay. Then these covalent compounds are three types I have taught you. Can you tell me what is the three types? Covalent compounds. They'll form three different kind of bonds. The bonds of a covalent bonds are three types. What is that? Anybody?
Single bond,
Yes.
double bond, triple.
Single covalent bond. We have importance of this one now. Next one is what? Double covalent bond. And another one is what, everybody?
Triple covalent.
Triple covalent.
Yeah, triple covalent bond. So we have importance of this also now in the carbon compound. So these are the three types of covalent bonds. And I have given you example for single bond and example for formation of double bond and example for formation of triple bond also. So if you are having the importance, if you're having the concepts of this only, this chapter will be, it is very, very easy. And once again, I'm saying number of above, suppose if I take a magnesium, many people in the exam, they don't know how to represent formation of magnesium chloride. Number of electrons, some people are putting like this. What is this nonsense? Only what is the, what we have to represent above the atom, everybody? Only we have to represent what electrons? Valence electrons alone you have to represent. Please remember, valence electrons alone you have to represent above the atom. So magnesium, what is the valence electrons? Everybody?
2.
What is the valence electrons of magnesium? 2. Chlorine, reacting with the chlorine. Chlorine, what is the valence electrons? Chlorine is 17. 17 means 2, 8, 7. So what is the representation, everybody? How many electrons? 7 electrons you have to represent in the chlorine. Am I right, everybody? Please respond. So wherever you are representing the formation of a compound, only you should represent valence electrons. Mr. Rohit, I am saying for you only. Do you understand it? Mr. Rohit, Arun Kailash, yaar, theriyade. How to represent the atom also. Only you should represent valence electrons above the atom. Do you understand what I am saying? Mr. Aswin Gokul also don't know anything. So you should know this all the things, and ionic compounds and properties and covalent compounds properties also. Whenever time permits, you should remember by tomorrow everybody has to learn this everything. And formation of compounds also, electron dot structure. Electron dot structure, I think I have given you more than 5-6 compounds. Am I right, Amma? Yes. So electron dot structure, everybody need to learn electron dot structure by tomorrow. Electron dot structure also we can call it as another name. What is that? Call it as Lewis dot structure. So if you know this one, then only it is very easy that carbons compounds we can finish it very, very simple. Extraction of metals, not only covalent bonds, ionic bonds, and as well as what is the electron dot structures. Please learn it and then we can come back to the chapter carbon and its compounds. So remember here the theoretical part and descriptive everything you study. So we know that carbon is the most abundant, like abundant means the important element in the universe. You can see the percentage of carbon is very, very less, but the carbon is having a greater importance in everybody's life. Every living organism is having a greater importance. So remember, the amount of carbon present in the earth crust, if you have taken earth crust, what is the symbol of carbon, everybody? What is the symbol of carbon? Yes,
C.
please. C. So it is a metal or non-metal? It is a metal or non-metal? Everyone. It is the non-metal. And it is derived, a carbon is a word derived from a Latin word meaning carbo. So carbo means, which means a coal. That is the meaning where the carbon word has been taken from carbo, a Latin word. So if you notice it here, why it has been taken from the carbo? Because coal is the, what is the main constituent of coal? Anybody can tell? What is the main constituent of coal? All of you, carbon. So that is why it has been chosen as carbon. So carbon is the element which is a non-metal which has been taken from the Latin word, call it as a carbo. So if you take the earth crust, the present of the carbon present in the earth crust and as well as in atmosphere, but it is present in very, very small amount. So if you have taken the carbon present in earth crust, only it contains 0.02 percentage. 0.02 carbon, that is also not in the free state. Not in free state. What do you mean by free state, everybody? Purely carbon. So it is present in the form of minerals. So under the earth crust, it is just 0.02% carbon in the form of minerals. That is also. So very important. In form of minerals, it is existed just 0.02 percentage. Like, sir, what is the minerals? Can you tell me what is the carbon minerals which you studied in second chapter, third chapter, everybody? Yes, please. Carbonates, very good. That's
Hydrogen
all.
carbon.
Yes, carbonates and bicarbonates, and as well as coal. Of course, coal is a pure form. It is coal and as well as petroleum. So these are the sources of carbon under the earth crust. And if you have taken atmosphere, it is only present in combined form. Can you tell me what is the form which is present? Atmosphere. Used to study that.
Carbon dioxide.
Atmosphere, it is present only carbon dioxide form, which is, what is the percentage? Everybody, carbon dioxide percentage, 0.03 percentage. So it is extremely smaller. Present of carbon in our nature is very small, but the importance of this carbon is extremely high because even our body is made up of carbon. If there is no carbon, if there is no life of an organism. So that is the importance, immense importance in every part of living organism. So that is what the importance of carbon. Even every living organ, many kind of substances is made up of carbon and its compounds only. So all the living things, plants, animals, everything is made up of carbon-based compounds. So that is why all the living things, including the human beings, we used to call them as organic compounds. So which is made up of carbon, which we used to call it as a organic compounds. Clear, everybody? So class 11th, you made this chemistry into two types. One is organic chemistry and another one is inorganic chemistry. So this is what is organic compounds. So all the living beings is made up of organic carbon. That is what we used to say organic compounds. So if you take very large number in our daily life. Many items is made up of carbon and its compounds only. If you take the food materials, whatever it is, grains, pulses, sugar, tea, coffee, fruits, vegetables, everything is made up of carbon. If you take the materials like cloth, silk, wool, nylon, polyesters, which is used, they are also what? Carbon compounds. If you use the fuels, what is the fuels you are using? Wood, petrol, kerosene, LPG gas, natural gas, CNG gas, everything is actually whatever you are using for cooking food, whatever you are using for running the vehicles, all are what? Everybody, all are carbon compounds only. If you take now, you are writing the classwork, paper, you are using a rubber for erasing, rubber, you are using a pen, plastic, you are using a leather, you are using a medicines, many medicines, that's what drugs, you are using a colors, dyes, all are made up of carbon compounds. Just imagine if there is no carbon, imagine these are the items will never available. 99% of the substances what we are using in our daily life, definitely a carbon containing compounds. That's what carbon and its compounds. The percentage of carbon is extremely smaller, but the importance of carbon is extremely higher. None can define without carbon. So we can see the presence of carbon in a material. If you notice it, in the basis of carbon and its like combined form, it is always presented. Sir, how you can see carbon is present or not? If you test the presence of carbon in any material, I said you food items, I said you the fuels, I said you the materials what you are using, I said you dresses what you are wearing, if any material, sir, I want to test it either it is a carbon and its compound or not. Means it's a very simple, just carbon and its compounds. If you burn them, note it everybody, if you burn in air, understand, they will give you carbon dioxide gas. Sir, how sir you can verify carbon dioxide gas is releasing or not? How we can verify, guys? Carbon dioxide gas is releasing or not? Anybody? By passing the what?
Passing lime water.
Yes, which turns lime water into what? Everybody?
Milky.
Lime water to milky. So if you burn any substance in our home, if you burn any kind of thing, if it will gives you carbon dioxide and it will turn up either carbon dioxide, always what it will be happen? Everyone, it will turn into milky, lime water into milky. Then it is definitely contains carbon. So that is what is the test we will use it for making carbon. Are you clear, everybody? Carbon is compounds. So now carbon, if you have taken, most important thing what I am saying you. So carbon, if you have taken, so what is the atomic number of carbon, everybody? What is the atomic number of symbol first? What is the symbol of carbon? Make it quick. Carbon symbol is what? C. What is the atomic number of carbon? Make it fast, guys. Atomic number of carbon. All of you. Atomic number of carbon is how much, guys? 6. The symbol is Z. Atomic number symbol is Z. 6. So what is the electronic configuration? Everybody? What is the electronic configuration? All of you.
2,4.
Yes. Electronic configuration is 2,4, means K and L. So what is the valence electrons? What is the valence electrons? Everybody. Valence electrons. Valence electrons are 4. So valency also. What is the valency, everybody?
4.
What is the valency? 4 only. Clear, everyone? So because of this, you can remember it is not possible to remove the 4 electrons from a carbon atom, or it is not possible to add 4 electrons to a carbon atom, since carbon atom cannot gain the electrons or not the electron, receive the, donate the electrons or not accept the electrons. That is why it will achieve the nearest inert gas electron arrangement only by what, guys? Everybody, only by sharing of electrons. Sharing of electrons. That is the reason carbon always forms what bonds? The most important point you have to remember. Carbon always forms what bonds, guys?
Covalent bonds.
Covalent bonds. Please remember that. Okay, everybody. So carbon always forms covalent bonds because it will achieve the inert gas electron arrangement. Write it. It can achieve, carbon atom can achieve the inert gas electron configuration. Inert gas electron arrangement. What is the nearest electron arrangement? Anybody? Carbon? Three? Nearest electron arrangement. Electron arrangement only by sharing of electrons. Nearest electronic configuration, guys. Sharing, by sharing, it will attain the nearest electronic configuration of home. 2, 10, correct. Sharing means 8 it will get. So what is that?
Neon.
Neon. Period means what I can.
What helium, sir?
Helium, not Hari. By sharing, that's what. By sharing, it will attain what? Valence shell 8 electrons and inside 2. So 8, 2, what is that? Nearest inert gas electronic configuration. Neon. Do you understand, Hari?
Yes, sir.
Yes. So why carbon always forms covalent bond? Everybody? All of you. What is the answer? Why covalent bond always? Because what is the atomic number of carbon? Atomic number of carbon is 6. Electronic configuration is 2, 4. Valence electrons is 4. Valency is also 4. If valency is 4 means what? Neither donating nor receiving. Do you understand, everybody? Neither donating. It is not possible to remove the 4 electrons to give the inert gas configuration. It is not possible to add 4 electrons because energy is considering. You will study in 11th class there. So it is huge amount of energy is required to remove the electrons or to add the electrons. So it is obviously to acquire the inert gas structure of 8 electrons in its outermost shell. It is the one and only way is what? Everybody, by sharing of electrons. So that is why, since carbon atom can achieve the inert gas electrons arrangement only by sharing of electrons, so it will always will form what bonds? Everybody? What bonds it will form? Covalent bonds it will form. Are you clear, everybody? That is the most important thing. Sanjay, any doubt, Sanjay? Every point I'm saying you, board exam if it comes, can you prove it? Why the carbon always forms a covalent bond? Every point you write it. Nobody can cut the marks. Do you understand, everyone? Because you can remember why. What is the exact reason I'm saying? This is extra point for others also. Sir, why can't carbon can lose the 4 electrons? Why can't we cannot add the 4 electrons? As I said, energy considerations. So the carbon size is very small. Carbon atom size is very small. Atom size is very, very small. This point note it at the others also. Very small. You can see, due to which the outermost electrons are very, very strongly holded by the nucleus. So it is not possible to remove. Why we cannot remove the 4 electrons? Why can't we add the 4 electrons? Adding 4 electrons, remember, add 4 electrons need a lot of energy. Energy consideration. Energy consideration is very, very high. Removing of 4 electrons, it is not possible because the size of the carbon is very, very small. So the outermost electrons, please write it, outermost electrons are strongly held by the nucleus. That is the reason for carbon we cannot remove the electrons or we cannot add the electrons. Are you clear, everyone? Do you understand, everyone? That is why they will undergo what? By sharing of electrons. Clear? All of you? Mitachri? Abhirami?
Yes, sir.
Yes. Hari, those who join now too, these two also remember. I want to throw them, this all idiots. They don't have even minimum sense. So this is what? Next. Carbon, as it is, valency is 4 and valence electrons also 4. It needs how many electrons to achieve the inert gas stable electronic configuration? Anybody? How many electrons it needs? Everybody? 4 electrons. That is why carbon is a tetravalent compound element. Carbon is a tetravalent one. So it needs to acquire the 8 electron inert gas arrangement. How many electrons it needs? Everybody, please respond. 4 electrons it needs, which it will gets. 4 electrons, which will gets only by what? Only by sharing or by donating or accepting? Everybody? Only by sharing. Okay, so write the statement. A carbon atom has 4 electrons in its outermost shell. Carbon has 4 electrons in its outermost shell. Pugal, are you writing the notes? Sanjay? Carbon has, carbon has 4 electrons in its outermost shell. So it requires how many electrons, everybody? It requires how many electrons?
4 electrons.
4 electrons. It requires 4 electrons to achieve the stable, 8 electron, stable, 8 electron inert gas configuration. Because when we can say atom is a stable, when it is an element is a stable, when it is having how many electrons in its valence shell? Everybody? How many electrons? When we can say how many electrons is required to become a stable in nature, in valence cell?
8 electrons.
8
Correct,
electrons.
8
8 electrons, inert gas electron arrangement. Those who are not taking notes, please don't attend from tomorrow. I'm very, very concerned about this chapter. Very, very serious, I'm saying. So this all the required 4 electrons, it will get only by what process, everybody? Only by sharing only. So since one carbon atom requires 4 electrons to achieve the 8 electron inert gas structure, so we can say the valency of carbon. What is the valency of carbon, everybody? It required 4 electrons to achieve 8 electron inert gas configuration. So that is why, what is the valency of carbon, everybody? What is the valency of carbon?
4.
Please. 4. That is what? Carbon is a tetravalent. Carbon is a tetravalent. It needs 4 electrons to achieve the 8 electron stable arrangement. So tetravalent. What do you mean by tetra? Tetra means 4. Valent means valency. So 4 valency. 4 electrons is needed. That is what we used to call it as a tetravalent. And you remember the 4 valencies of carbon usually represented by